In this video, we are going to teach you the acceleration due to gravity on Earth and how to solve equations relating to it. So if we were in a vacuum with no air resistance, which would fall faster, a heavy textbook or a feather? Well, common intuition would tell us that the heavy object would fall faster simply because it has more mass bringing it down. However, the feather would actually hit the ground at the same time as a textbook.
Because they are in a vacuum without the force of air resistance, they are in freefall, meaning that they are only affected by the force of gravity. And on Earth, gravity accelerates all objects at exactly the same rate, regardless of their mass. This acceleration due to gravity is 9.81 meters per second per second. So that means that each second, their velocity increases by 9.81 meters per second. So after 1 second falling in the vacuum, both the textbook and the feather are traveling at 9.81 meters per second. After 2 seconds, they double that velocity, and are both falling at about 19.62 meters per second, and so on. All free-falling objects accelerate at that exact same rate.
But of course, as you've probably noticed, objects do fall at different rates based on their mass or size, and that is because air resistance affects objects with different masses and areas differently.
Yeah, good point. So while the acceleration due to gravity is the same for a textbook and a feather, the air resistance will affect a feather more.
Exactly, which causes them to fall at different rates.
Let's try to figure out how fast free-falling objects will be falling after a certain period of time, neglecting air resistance. To solve all problems, we can use the equation final velocity equals initial velocity plus acceleration times time. And this makes sense because if we know how much an object speeds up per second, then we can simply multiply the number of seconds to find its final speed, and add in how fast it was traveling at the beginning. If I drop a rock over a cliff, how fast will it be falling after 4 seconds?
Using the acceleration due to gravity, 9.81 meters per second squared, in this period of time, 4 seconds, we can calculate how fast the rock will be traveling. Because there is no initial velocity, all you have to do is multiply the acceleration by the time. 9.81 meters per second squared times 4 seconds equals about 39.24 meters per second.
Now, how about you try a problem on your own? How fast would the rock be traveling after 5 seconds if you threw it downwards at 40 meters per second? Remember, it is the same equation as the problem we did together, except there is an initial velocity this time. Pause the video and resume it after you're done.
The acceleration is still, as always, 9.81 meters per second per second. The time is 5 seconds, and the initial velocity is 40 meters per second. So you can multiply the acceleration and the time, and then add the initial velocity this time. So 9.81 meters per second times 5 seconds plus 40 meters per second equals 89 meters per second.
All in all, gravity accelerates all free-falling objects at the exact same rate, regardless of their mass. This acceleration is 9.81 meters per second squared. To learn more about this topic, search acceleration due to gravity into the search bar at ck12.org.